In section 3, we want to look at finding the zeros of polynomials. I'll start by just looking at a few of the terms and the general idea. The question here is asking, is x plus 3 a factor of this polynomial? Well, if x plus 3 is a factor of that polynomial, then when we divide the polynomial by x plus 3, we should get a remainder of 0. Now, this is one that we can use synthetic division on. So if we do synthetic division, notice the remainder comes out to be negative 16. Now, since that is not a 0, x plus 3 is not a factor of that polynomial. Here's another one that asks, is x minus 4 a factor of this polynomial? So again, we want to do synthetic division. Now remember, the x minus 4 means we want to use synthetic division with a positive 4 out front. Since we came out with a 0 as the remainder, that means it is a factor. Now, all this is actually called the fundamental theorem of algebra, which says that if you got a second degree polynomial, quadratic, then you have to be able to come up with two linear factors. If it's a traditional x squared function, we can factor it the traditional way. However, if it is something like this, that does not factor by the traditional way. And so to do that, we would have to be a little bit more creative. Now, what we can do is recognize the relationship between zeros and factors. If we solve the quadratic equation x squared plus 4 equals 0, like on our calculator, then we get the answer 2i and negative 2i. Well, if x is equal to 2i, then the factor is x minus 2i. And if x is equal to negative 2i, then the factor is x plus 2i. So again, there's two factors. Here's one. We can actually do this by the traditional way. We can factor this into x times x squared minus 4, and we can factor the x squared minus 4 into x minus 2 and x plus 2. So you can see the three factors. Third degree polynomials have three factors. Now here's what the steps are for finding this. We'll start by drawing the graph on our calculator. So if we've got a TI-84 calculator, we can take a polynomial like this, type it into our calculator, and draw the graph. Now, we are looking for, the term sort of implies, zeros of the polynomial. Now, the term zeros of the polynomial means where is the y value 0. And the y value is 0 where it crosses the x-axis. So sometimes we may even be asked to find the x-intercepts. Finding the zeros is the same thing as finding the x-intercepts. It looks on this graph as if the x-intercept is negative 1. So we will now do synthetic division with negative 1. So here's the synthetic division. So add, multiply, add, multiply, add, multiply, add. Since we get a remainder of 0, then x minus 1 is indeed 0 of the polynomial. And so if x minus 1 is a 0 and and it's x to the third degree, we still have to find two other zeros. Now, after you've done the synthetic division, the 1, 10, and 29 tells us this is the quadratic, x squared plus 10x plus 29. And we can solve the quadratic by using the quadratic formula program on our calculator. If we run our quadratic formula program, you can see we get negative 5 plus 2i, negative 5 minus 2i. So these are the three zeros for that polynomial. Here's a third degree polynomial. The question is if x minus 4 is one factor, what are the others? And so, since we know x minus 4 is a factor, we will do synthetic division. And again, we better come up with the 0 at the end because they said it was. And then the 1, negative 2, and 1 is the remaining quadratic that we now need to solve, which we'll do on our quadratic formula. And so these are the three factors for x cubed minus 6x squared plus 9x minus 4.